Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and with me is Phil Japikse.
Hey, Robert.
Hey, Phil and I are continuing our series on design patterns.
Correct.
And today we are going to talk about the template method pattern.
True. So let's, as we've done with the other ones, pull up the definition, courtesy of Wikipedia. And the template method pattern defines the program skeleton of an algorithm in an operation, deferring some steps to subclasses. Whole lot of mumble jumble words, right? Really what we're talking about is we want base classes to have specific implementations of certain steps of a process.
Okay.
Right? We want the process to happen in the right order. We've been using the e-commerce example through all the episodes so far. Take the order, pick the order, pack the order, ship the order.
Right.
Think about making a pizza. You certainly want to take the order, process the payment, which we forgot to mention just prior. Make the pizza, cook the pizza, cut the pizza, box the pizza. Well, we got to box it.
Box it.
Right? See, that's where we have a template.
Assume, well, maybe, or plate it.
Or plate it, right? Well, let's say it's going out for delivery.
Yep.
So you don't want to get that order messed up.
No.
Right? You don't want to put it in the box and then put it in the oven. That would be bad.
Right.
So we want this.
But that can't possibly be the pattern.
No, that's
Do
not
things
the pattern.
in the right order.
No, but that's part of it, right? So we've got this template to do things.
Yeah.
Right? So defines the program skeleton of an algorithm. So the algorithm is, how are we going to make this pizza?
But it's the deferring some steps to subclasses that makes it part of the pattern.
That's the
Because
pattern.
if it's just, oh, what are the 5 steps you need to do to make a pizza? Get them in the right order. That's not the pattern.
No,
That's
because
just,
you could do that with the command pattern.
Right. You could do that by writing the right code, for crying out loud.
Well, yeah.
Right. Okay.
So you can redefine certain steps of an algorithm without changing the algorithm structure, right? So let's say if cooking the pizza, you're only going to half bake it, or you're going to twice bake it, or things like that, right? So a derived class can change how that particular step works, but I haven't rewritten the algorithm. The algorithm itself is still the same.
Cool.
Right?
All right.
All right, so let's look at the code. And this is one of the rare ones where I don't have unit tests around it, but it's a pretty self-explanatory pattern. But I think there's a lot of
pizza. It's going to pass.
Yeah, there's a
Pizza's
lot
good.
of pizza is good, right? It's how you get all the developers in one room, right? You bring in free pies. So here's my abstract base pizza store.
Okay.
And I have to thank you know what? We haven't been mentioning resources in the other episodes, but one of the things that we're going to put in is a link to the Head First Design Patterns book, and we'll put that in all the show notes.
Awesome book.
And so I want to thank them for inspiring the whole pizza theme that we'll see in several other patterns as well. So here are pizza steps. Take the order, process the payment, make the pizza, cook the pizza, deliver the pizza, and then we're returning this out of the method. Didn't really need to do that.
Okay.
But we are, and we've got some things that aren't going to change regardless of the type of pizza.
Right. Okay.
Processing the payment and delivering it happens the same regardless of the type of pizza. I'm going to charge a credit card. I'm taking cash. However that works, got to calculate the price. Calculate the price might be something that varies, but not actually processing the payment. And delivering the pizza is the same across all pizzas as well.
It's entirely possible that depending on the pizza you make, you could deliver it differently, but
it is possible, and then you would have to extend this to override that. Right?
Okay.
So we've got these base implementations for processing.
So it's the fact that take order, make pizza, cook pizza, that's always going to happen, but how it happens can be different, and therefore you put it in an abstract class. That's what makes this the template method pattern.
Yeah, and to be clear, it doesn't have to be abstract. I could have made those virtual and have a standard implementation, which, for example, we could have done with the deliver pizza.
Okay.
So if it's a hot pizza, it's always delivered the same way.
Right.
But let's say you're going to deliver a half-baked pizza, right? The one that you finish cooking at home. Maybe that has a different delivery style.
Right.
Maybe it has to be refrigerated.
Okay.
Who knows, right?
But the fact that the implementations of these live somewhere else and are brought in at runtime That's
Yeah.
what makes this the
Go-
template method.
Going back, well,
Okay.
they're actually
Eh?
brought in at design time, not
Design
run
time.
time. Because we've got these classes built. We're not changing the implementation at runtime.
Okay.
We're defining the implementation at design time. At runtime, we could
Yeah, yeah,
pick
yeah.
a different style of pizza store, but that's not the strategy pattern. We're just picking a different implementation,
Okay.
right? So again, we've got the program skeleton defined, and we're deferring some steps to subclasses.
Mm-hmm.
So we've deferred the make pizza, cook pizza, and take order to a subclass.
Okay.
Now, the reason to take order, I love my Chicago style pizza.
Mm-hmm.
My wife loves the New York style pizza, but you take the order differently, right? Because it's a different set of ingredients and different options. So that really needs to be subclass. So I've got my New York style pizza store. And there's no real implementation here because, again, I'm just trying to show the pattern.
Right. Okay.
But for take order, I'm going to operate on this pizza for delivery, which is defined in that abstract class. That's the iPizza in the abstract class. And this is probably a great place for the basic factory pattern. We haven't aired that show yet, but it will be coming up as part of this series.
Mm-hmm.
But just know that we're going to return some sort of iPizza. Probably be a thin crust. It's New York style, spicy ingredients, lots of sauce, right? Then we're going to make the pizza, and it's going to be thin crust. So we have to cook it less, right? If it was Chicago style pizza, we'd have to cook it longer,
Yep.
right? So that's a specific implementation that is deferred to the derived class. Make and cook, right? Both fall into that,
Right.
right? So probably cooked in a wood-fired oven for New York style pizza and a different style of onion for Chicago style pizza.
Right.
So that's the crux of the template method. One thing that you'll notice when we get to the factories,
So you would then have a separate class for the various types of pizza.
correct,
And if you created a new type of pizza that you were offering, you would just have a new class, different style pizza store, which still has a take order, make pizza, cook pizza. The steps are the same, but how you do it is differently. But regardless, you're always processing the payment and delivering in the base class.
correct.
Okay.
And what you just maybe inadvertently called out is one of the problems with the template method is if I have a Upper East Side style pizza where the only difference is maybe the types of ingredients, not pepperoni, cheese, but the type of cheese or the type of pepperoni. Now I have to create a whole new derived class to handle that one method,
Okay.
right? When we get into the factory patterns, and there's two in an honorable mention, but we'll just call it three, you'll see where it takes the template method and fixes that problem. But for a lot of implementations, this is great because, again, going back to that e-commerce thing, if I have probably the level I would do is books, perishables, fragile, right? And so again, taking the order, processing the payment, picking, packing, shipping. But if I know that perishables need to be shipped a certain way and packed a certain way, and fragiles versus books or things like that, right? So now we've got the take order and delivery in the base class. I'm going to send it out to UPS or United States Post Office, or I got to make sure I hit everybody since you don't have sponsors, FedEx. I'd be like NASCAR here. I'll just have stickers all over
There
me
you
for all the
go.
delivery
There you
companies. Yeah, that would be the template method, right? So
Okay.
we've got this base. But you can have an explosion of classes with this.
Right.
Because every time I need a variation, now I'm making another.
Yeah. Now, I could also implement this using the strategy pattern, right? Where where the take order, make pizza, and cook pizza change at runtime based on the type of pizza that's being ordered?
Yes.
As we covered the strategy pattern in the
yep.
previous episode.
And-
So how would I know which one to use, or how would I decide?
Well, some might say it's a coin flip.
Okay.
I would say that this is probably not the strategy pattern because you're really not changing at runtime. You're going to know ahead of time that this type of pizza gets cooked this way.
Okay.
And this other type of pizza gets cooked this other way. Now, if you wanted to take a Chicago-style pizza and not cook it all the way, then maybe that's a strategy pattern, right?
Or maybe you should just make pizza the right way.
Well, or you're stuck in a hotel that doesn't have an oven and you bought a
Okay.
DiGiorno pizza and you're trying to cook it in a pan. So, which by the way doesn't work. I can tell you from experience. So, but that's changing the implementation at runtime
Okay.
as opposed to at design time, right?
Got it.
So at design time, I'm changing it because I'm pulling in a different class.
Right.
I'm instantiating a different
Yep.
object of that interface,
Got it.
right? At runtime, it's still, for the strategy pattern, it's still the same instance.
Mm-hmm.
I'm changing its behavior at runtime, not picking a different implementation detail.
Okay. Makes sense.
Yep. So we talked about some of the drawbacks that you could have code creep, right?
Mhm.
And just explosion of classes. But this is kind of the first time we mention patterns aren't in isolation normally. Some kind of are, like the simple factory pattern you don't normally combine with a lot of others. But even when we look at this, what kind of screams out at you where I've got take order and make pizza and deliver pizza? You already said it. That's like the command pattern, right?
Yeah.
Go do something. I don't care how it gets done.
Right.
Just go do it, right?
Mhm.
So now we've got the command pattern tying into the template method.
Yep.
We're also going to see that in the factory patterns and lots of different places. So while the command pattern and Memento were pretty simple to talk about, the reason I felt they needed their own show is because they're foundational to so many others.
Okay.
And we're going to keep seeing this recurring theme of how these all work together.
So let's say process payment and delivery pizza also changed based on the type of pizza. So all 5 of these methods were in a different class.
Okay?
Is it still the template method pattern?
So by definition,
What if all of the
if
functionality?
all of them, then we would actually be looking at the factory method
Okay.
pattern,
Okay.
which they're very similar. And I thought about doing them together like we did the command and Memento, but they're different styles of patterns. This
Okay.
is a this is a behavioral pattern, and the factory is creational.
Okay.
So, and again, it's an arbitrary, it's not arbitrary. Some wicked smart people, when they put their book together, came up with these definitions. But I never sit there and code and say, well, I need a behavioral here and go through my list. I'm looking at this code saying, how has this been solved before? And I remember patterns. I don't always remember which category they're in.
Right.
Right. So you're going to see some that are similar, and they're cousins, sometimes second cousins, sometimes they're not related at all. But that's pretty common in software design, right? Because there's really nothing new that we're doing in software. I mean, there's new tooling,
Sure.
and there's new processes like agile and test-driven development and things like that. But at the end of the day, what we're writing gets translated into ones and zeros and goes through a processor and does something.
Right.
Right.
Mhm.
So
Yep.
I think that's it, though.
Okay,
I
cool.
think that nails it.
Template method pattern.
Yes.
Sweet. All right, hope you enjoyed that. See you next time when we'll look at another pattern.
Thank you very much.